We are given a solution that has some lead 2 nitrate and sodium bromide in it, and they are concentrated through evaporation. And then we're going to mix them again to form another solution, and that has a new molarity for each one of them. And what we want to find out is if a precipitate will form in the newly mixed solution. So where in the world do we want to start? Well, why don't we first start with the reaction? It says that we take lead 2 nitrate, and we add to that sodium bromide. And when I do that, remember you do the inside-outside. So I'm going to get PbBr2 to balance the charge and NaNO3. So that would be my equation. Now is it balanced? No, you got to put a 2 here and a 2 here. So for this reaction, we know that KSP equals 4.67 times 10 to the minus 6th, and it is soluble. Okay, that's great. So how's that going to help me? Well, I know that when I'm looking at precipitation, I can look at the Q value and compare it to the KSP value to find out if it is unsaturated, saturated, or supersaturated. So let's do that. So Q is going to equal to the concentration of the ion. So I've got Pb2 plus times the Br minus, and there are how many of them? There are 2, so I have to square that. So what is the concentration of the lead after mixing? So that's going to be this one, and then this is going to be for the Br after we mixed it. So it's going to be 0.0600 times 0.0158 squared. I'm going to do that calculation, and I get 1.4978 times 10 to the minus 5th. So I need to compare Q and KSP. So here's what I found for Q, the 1.4978 times 10 to the minus 5th. And then I have the KSP from previously, which is 4.67 times 10 to the minus 6th. Now, how do those relate? Well, if I look at the exponent, this is a minus 5, this is a minus 6, so the Q is greater. And when it's greater, what do we know? Well, we know that this is a supersaturated solution. So, will a precipitate form from this newly mixed solution? The answer is yes.